restart that because. Okay, yeah, so we're just reopened this model, hierarchical infection model V1, and right now a person exhibits one type of dynamics. They exhibit migration, right? So they move from city to city. And you may remember that. They'll move from one city to another, back and forth, coming into here, okay? Great. So we're going to add some additional dynamics that will lend texture to that movement. We are going to associate this person with a health status, and in fact, health status with respect to a communicable disease, a disease which could be brought from one jurisdiction to another. So you're going to tell me what to do. I want to put in place, as Kurt led you on yesterday, a model of susceptible an infection where people can be susceptible, they can be infected, they can be recovered, but they also their immunity wanes over time and they go back to susceptible. This would be a bug like chlamydia, gonorrhea, or other fast mutating infections. You could say flu if you considered the mutation that goes on from year to year with flu. In this case, we're going to also have a latent period. So people could be SEIRS. They could be susceptible, they could be infected, but not yet infectious. We call it E for exposed. They could be infective, or they could be recovered, and then they'll cycle back. So what do I add to this person to capture that? We want to have a full-blown infection transmission model. How am I going to do that? State charts, indeed. Okay, so where do we go to add a state chart? Whence does it come? Agent, indeed. State chart entry point. Okay. Okay, so ladies and gentlemen, we're going to have infection state chart. And we're going to have susceptible. I'm tempted to call it latent. Traditionally, it's called exposed in mathematical epidemiology. I'll call it latent. Maybe I'll call it exposed. Infective and recovered. Okay. Okay. So susceptible. There we go. We're going to have exposed. Now, be sure to give enough room between these states. If you give too little room, what's going to happen is the name won't be shown in the transitions, and then sometimes it won't print out those statistics about when it will next trigger. Infective, and then recovered. Okay? Recovered. Okay. We're going to try to make this quick. Okay. Okay, ladies and gentlemen, we will now add transitions between each of those in turn, and then from recovered back to susceptible. Now, remember, when you add transitions, you want to make sure they are green on one side, and when you first connect them, then green on both sides when you finish. Yeah. So I'm going to go like this, and I'm going to pull them down. You could see how I kind of do it. I go and I connect them, and so I'm pulling them down. Now, for this connection back from recovered to susceptible, I do it in a way that was different from what Kurt did yesterday. Kurt did some sort of way that involved multi-clicking along there. And I think, did you get into this mode here, Kurt?
Just one individual said that they did that mode, and I didn't do that. But that's a pretty good way to do it.
It is. Okay, let me show you two ways you could do this to go back. So one way you could kind of go like this, and you could kind of bend it to your will in that way, and boom, and like that. You put these little handles on, and you drag it. That's not too bad. So in other words, to bend these things, you double click on it. There's also this mode that you can get in, which honestly I don't use, but I guess you can just draw like that and connect it up like that, which is admittedly pretty nice. So that's a mode. You actually have to get into that mode, you have to press this button, I think even twice. You double click on it, and it will get into that mode where you can start, click, and then click along the way, and then finish it, and it's and it will just drag it along the way. Okay, so we're going to start naming these things. Okay.
Maybe save and build it right now. Make sure you don't have any troubles.
Okay, sure. That's a good idea.
Probably won't, but
Good idea. So, ladies and gentlemen, when I do build, that's the thing with ones and zeros here. It says build completed successfully. Okay. Yeah. Those ones and zeros denote the fact that our models are ultimately built on this thing called binary, with ones and zeros in the computers. You've heard about that? I like to joke with, I teach my software engineering courses. I teach my students, and I'm getting on now in years, and they think I'm a real old guy. And I like to tell them, when I was young, all it was ones and zeros. And when this older professor in our department, Mark Kyle, when he was around and growing up, all the words were zeros. Sometimes it's lost on the youth. Anyway.
So mathematically, 0 was the last number to be.
Yeah. Good, yes. So, okay, ladies and gentlemen, so we're going to go name these things. So this transition from susceptible to exposed, it's good practice to name them and to make those names clear. It helps enhancing model transparency. This is going to be called infection, and we're going to show the name. And notice when you show the name, it actually underlines it. And in fact, when you select this, it will underline it, meaning you could drag it around. So you can orient it. For exposed to infective, we're completing latency, complete, and we'll show that name. And then from infective to recovered, this is going to be called recovering. Okay. Now Alan is interested in the aesthetics of models and how do we make models easy to understand aesthetically. How do we make them aesthetically pleasant? How do we add beauty to our truth? Beauty to our thinking tools. And if you're interested, you could speak with him. There's some tips that he will have that I, alas, do not, or it's likely to have. But there's a lot of ways you can make models very nice. And in fact, there's a certain set of conventions that to which I'm implicitly adhering here that are useful in terms of the flow of a model from top to bottom, left to right, that sort of thing. I don't have time to go into them, but Jeff and could talk with you about them too. Sorry? Sure. I will do that. Waning of immunity. So scroll up.
No, sorry, down. You were doing it recovering.
Yeah, recovering. Yeah.
Nate, you're going to know a lot more when you review that pretty sure.
Okay.
I'm going to give you some time to go home and settle.
I appreciate it, Alan.
Waning.
Oh, wait. Sorry, folks.
Sounds like a different equation.
Yeah, it's about 6 o'clock in the afternoon in Saskatoon. Okay, so here we go. Waning of immunity. Sorry, folks. Waning of immunity. Yeah. Okay, great. Okay, ladies and gentlemen, now what we're going to do is we're going to put in place a pattern that is a very common pattern in any logic, and it actually sticks in my craw a little bit. Okay, I have some misgivings about it, but it's very common, it's very useful, successful pattern, but it's a little bit imperfect. Okay, in its aesthetics. So, ladies and gentlemen, we're going to go now to main, and we're going to put in place some parameters for person, okay? Now that bothers me. It troubles me because really I would think those parameters best live with person because they have to do with person stuff. Generally, we have a separation of concerns in our model. We have person dealing with person things, city dealing with city things, main dealing with main things. But there are times where we put a parameter in main. Why? Why am I going to put a parameter in main? Things like duration of infectiousness and contact rate, duration of latency. Why would we put those in main? So we could change it in experiments, from experiment to experiment. So we'll often end up putting these things in main even though they really belong best elsewhere. Now, there's ways we can remedy that. There's ways we can get around that. But for many models, I live with it. I live with it. I wish it weren't so, but that's the way it is. Okay, so in main, we're going to add in some parameters. And you know, if this were a longer term model, I'd probably highlight this area and say person-related parameters, so it's very clear to someone browsing this that these are related to person. Okay, so I'm going to add a parameter. It's going to be duration of infectiousness. Infectiousness. Okay, what sort of parameter will that be? Will it be a double, an integer, a string, a Boolean, or it could be a double, but what else could it be? It's duration. It's a time duration. It could be a time duration. Okay. Okay, I see seconds here as the default, and I want to make sure that we're not dealing with a bad situation. I want to make sure our time units for the whole model are indeed correct. So I'm going to make its default value 7 days here. Let's go see what the model time unit is. I believe it's years.
Yeah. Does it say at the bottom?
Oh, beautiful. Thank you. Thank you, thank you. Grateful. That's really fantastic. Yeah. Thank you very much. So 7 days is the duration of this duration of infectiousness. You see, it's quite nice that we don't have to shoehorn that into years, right? Put 7 divided by 365 or something like that. That's the way it used to be in old times. Okay? Okay. Next, we're going to drag in duration.
Can I ask why you don't just put something like, I don't know, like again, you've got a default value for a parameter that you want to set on the outside.
Yeah.
You know, it just bothers me that you put in reasonable values for things that you are going to set, but your intention is to set from the outside.
Okay.
And then you don't know if you.
Okay, it's a good comment, Joe. So what I use is the default. So remember what a default is. A default is what I'm going to first emphasize what it's not. What it's not is the value that it has initially, which gets overridden by another value. The default value is if you don't specify a value for what will it be. And what I traditionally use that for is the baseline values. So we have a set of baseline values for parameters that are the values that we will use by default. And we're going to be using them 98% of the time, but we'll just have alternative scenarios which involve certain interventions and or certain counterfactuals where we vary those assumptions, but often we have a very well-defined baseline that consists of a set of values. And it's very convenient to be able to easily reuse those baseline ones and just change one from it, change a different one from it for this other scenario. And so the alternative of that is each time we create a new scenario, we have to type all the values of the parameters for that scenario. And I would argue that that may be a more error-prone process than just setting a clear baseline value associated with the parameter. But I will readily agree that it's a point for reasonable disagreement. You know, where different people might have different preferences very reasonably with respect to it. Yes, Kurt?
The other thing is, when you put the number that he puts in there, when you go to an experiment and you create a new experiment, it automatically puts that number
Right.
in that spot.
Yeah, I know.
Right?
Yeah.
So that means whatever number you put there is going to automatically be like, it basically is saying this is the number that you've already told me you want me to be, so it puts that number. And you can change it in the experiment, but you don't have to.
Yeah. Yeah. Yeah.
That's just sort of adding on to what he's saying. If you choose it as the default value, sort of your baseline, then it's easy to change.
But I would actually highlight one other thing that's very important, and it gets this issue of a motivation for doing it the way I happen to do it, which is that default value. It is true that it automatically fills that in, but maybe more to the point, it automatically highlights cases in bold if you change it from that default value.
Yeah.
So if you have a scenario where you've altered that baseline value in some way, it'll highlight that for you. And the reason it can do that is because it knows what the baseline value is. Gosh, sorry for deviating from the Queen's English. So it's the fact that we have a default value that allows us to highlight when we're using an alternative value. And for me, that's a useful thing, so that I'm clear when I run in a scenario what things I've changed from baseline visually. It's very clear to me. Dylan?
I'll point out one other thing that you can do with that default value. So let's say you're running experiments where the parameters really highly depend on one another or need to be within a specific range, or you want to make sure that in each new experiment you're actually setting those values. One technique I find useful, although I haven't had to use recently, is you can set that to a completely bonkers value. So to say, if you're specifying a rate, you can make it you can say the default is a negative value. So if you start your experiment without actually having thought through what you want that rate to be, basically any logic will say, nope, sorry, you gave me the wrong thing, try again. And so in a way, if you really want to be careful, if you really want to make sure that every single experiment you specify and really carefully think out what the parameters are, you can, I guess, kind of defend against your own carelessness in that sense by forcing you to get it right before the experiment will even run.
Right.
So I wouldn't say that's as common, but sometimes that can be a useful thing with the defaults.
I'd say in this area, what you're doing is you're balancing between two types of risk.
Yeah.
One is the risk of having not sufficiently thought through the values. Another is the risk of having a value that's the wrong one put in. It's a deviation from baseline put in that you didn't recognize as such. And for this method of actually putting in defaults, it's going to flag when there's a deviation from baseline, and so you'll be able to catch those sort of errors. But it doesn't force you to think through as consciously each and every one of the parameters each time. On the other hand, the method that you suggested, where you specify a value that's manifestly out of range, like 1 divided by 0, would be a classic. Mm-hmm. You could put in here for the default value 1 divided by 0, and if this is ever used, it will blow up. It'll blow up. It'll stop the model for you, say, full stop, go fix it. And that could be useful for forcing you to be very conscious about what values you've chosen, but it's not going to highlight few deviations from baseline because it doesn't know what the baseline is.
Yeah, and the reason I bring that up is I get the feeling from your concern that you want to make sure that the parameters are set for a specific thing and you don't want the baseline necessarily to be used in every experiment. Is that correct to get through?
It depends on how you think about it. From what Nate says, you're just creating a model, and then what you're trying to use this for are essentially sensitivity analysis by varying things. So you have a model, and now you just want to vary it for sensitivity analysis, and this way is fine. But if what you're putting in is just like haven't thought about the value yet, here's a value that I'm putting in to plug it, then I have issues. Do you know what I mean?
Yeah.
If you know what the values are and this is exactly what you're going to model, and then you want to do a sensitivity analysis on it, then that's fine. You know, this approach is fine. I suppose the word default doesn't necessarily imply that necessarily. Do you know what I mean? Like,
Yeah. No, I know what you mean, and I think
so
I think you're exactly right. There are these two different kind of ways you might use a model. So totally agree, and as I say, I think both are perfectly reasonable stances, and both might be applicable in rather different circumstances for the default. So I'm just continuing on here for defining these parameters. So we're going to have duration of infectiousness I gave is 7 days. We could have said 1 week, right? Maybe we'll play to that strength. 1 week. We'll hope the Krugerian determination is accurate. Duration of latency is going to be 3 weeks. Okay, 3 weeks. 3 weeks. Duration of immunity, right? We're going to say is it's let's say 7 months. Or excuse me. Thank you, Jeff. Yeah. So okay. So when do you think we should do it? Soon. Okay. We'll just say 270 days for that. Okay. Contact rate we'll put in. And what sort of parameter will that be? There'll be a rate parameter. Okay. And it's going to be a per day parameter, 1 per day. And then there'll be a final one called transmission probability. Transmission probability. And this one will be, ladies and gentlemen, 0.5. So that's transmission probability for per discordant contact. So if there's a contact between a susceptible and infective, it will, that's the probability that transmission will occur. Okay. So that's good. Maybe what we'll do is, I've been told the food is here, so I think we'll stop for 15 minutes. And we'll resume, okay?